We are live.
All right, welcome everyone. This is our first Wolfram Institute Community Forum. So almost every day we have live streams. Many of the live streams are essentially internal research meetings that we broadcast publicly for everyone's benefit in pursuit of our open science policy. But today we're having our first community forum, and the purpose of these community fora is to engage with you all. So you might have questions, you might have comments, you might be interested in what we're doing, and we just want to dedicate this time to an open, dialogue with you all. So I know that we have some questions that we've received on our Discord, and if you're not on our Discord, you can join it, and the link to join it is on our website. You can post that actually if you
Yeah, just
want.
posting it.
Post that right now in the chat. Yeah, I'm just posting it. Um, and so I think Carlos actually has collected some questions that we have from the Discord. We can just answer those just to initiate this dialogue with our greater community. But as we proceed, if you want to pose a question in the chat, then we will read it out loud and we'll be happy to respond. So anyone who's watching the live stream who has access to the chat, feel free to ask questions there. Carlos will read them and we'll do our best to field those questions and say what we can about them. Okay, but Carlos, you've prepared actually a list in advance, which is very helpful. So,
Yes.
okay,
So
all
so
right,
there's a few things that people have. I mean, I don't know exactly what order we prefer, but because there are some questions that are more about content and research, other questions more about goals and objectives. So I think both from. Let me see if I can find it exactly, so I can name the person. Uh, no, it might have been over email. Some of the research affiliates, which at some point we should also comment on, and what their role is and everything.
yeah,
They were asking about, what is the purpose of this institution. Obviously, we had our launch a couple of weeks ago, but
yeah,
perhaps
sure.
we can say a few words about just what is the general scope of the institute, what are the midterm goals, what is the reason for existence for this project.
Okay. Oh, that's a great question. Yeah, I can answer that. So, if this is coming from a research affiliate who has a background in physics and who would collaborate with us on physics, then I might tailor that towards that kind of person in particular. But then I can generalize the answer to make it relevant to anyone. Okay. I mean, so with respect to physics, so there's this thing called the Wolfram Physics Project that was launched in 2020, and for those who are familiar with Stephen and his kind of career, Stephen began as a teenage particle physicist, and he led a scientific career for many years before. Well, I'm skipping over a lot of details, but before founding Wolfram Research, and he did new kind of science, and we can discuss the kind of methodological legacy of new kind of science, which we certainly uphold. And many of us have really learned from Stephen about doing computer experiments and kind of the study of computational behavior as kind of a key methodological approach. But then Stephen spent, many years just working basically as a CEO, building a Wolfram language, creating Wolfram Alpha, et cetera. So the physics project was this kind of return on Stephen's part to science, and he gathered many people around this physics project, and there was quite a bit of excitement in 2020 about this new development. However, there was no real institutional vehicle for the physics project, so it was kind of pushed forward and held together by a kind of a community of volunteers, of people working part time, and that was great. I mean, it was great to see people, even if they were doing it basically in their own spare time, or if they were collaborating with others from around the world and writing papers of various kinds with various degrees of kind of relevance to the computational thrust that was proposed by the physics project. It was really nice to see that being undertaken. However, this kind of a radical research program, in order for it to kind of push forward with any kind of momentum, it really needs a proper institutional home. So that is actually one purpose of the institute, is to onboard research fellows who will work on the physics project on a full-time basis. And so, if you take Nick, for instance, Nick is a physics fellow. Nick is working on the physics project and is working on it full time. Now, there are several benefits of having fellows working on the physics project full time. I mean, one thing is just you'll get more done because people are really available to focus on this seriously. But there are really two other kind of key benefits. One thing is when you have an institution, not only do you have, say, capital flowing in from donors, and you can allocate that capital towards fellows, and so you're able to buy people's time so that they can give full attention to a project. That's one thing. But also as an institution, part of your character, part of your persona, your reputation, your ethos, yeah, that's better. Part of your ethos as an institution is the paradigm and the methodology that actually informs your research. So, in the particular case of the physics project, the idea is that, in the past, we've studied kind of the behavior of different computations, and sometimes this is used to model or approximate real-world behavior. The physics project is a kind of a grand, bold new advance in that area, because now we are still continuing to study computational behavior, but we're developing quite elaborate, quite extensive models where different kinds of behaviors are interpreted as encoding or exhibiting properties of physical quantities, physical features of our universe. So this is a sort of an unprecedented, massive undertaking in computational modeling, and there's basically two things to be said about that, right? The first thing is that this is certainly in line with this kind of legacy of computational-based research, study of computational behavior that Stephen has helped to pioneer. But it also requires the introduction of many new methods and concepts, and even the augmentation, verification, and just the overall evolution of this methodology with new concepts, with new frameworks, things like multi-computation, the Boolean, and other ideas that are brought forth by our fellows based on their past experience. So what you really need, and what we're doing is, we have this institute, we have the capital, we have a community that we're growing, and so we get the license to develop sophisticated, serious, accountable new methodologies for doing this work. It's open. There are no tricks. There's no sleight of hand. There's no sleight of hand. All of our code is made available in the publications. The code is freely available. And so what we want to do is we want to, make radical innovations on the methodology side. This might lead to unconventional findings. We might have things to say that that challenge certain prevailing areas of certain prevailing ideas, for lack of a better term, in different areas. And really, the purpose of having a real institute like this is to really engage with people, to be quite open about the work that we're doing, to engage with supporters, to engage with our community, to find people who are interested in supporting us in terms of donations and funding us, and taking this as something with a strong social presence and with real capital backing, and making a significant change to science. You need a real institution as a vehicle for attracting and employing and encouraging and rallying people, both on the science side, on the community side, on the financial side. You need a kind of a machine to put all these factors together to really make some sort of new contribution to science. So the physics project is one case of that. I'll say one other thing, which is, so when I joined Wolfram Research, I was Stephen Wolfram's research assistant, and we were working on the generalization of certain kind of general framework features in the physics project to other areas. And so Nick and I worked on really one of the first generalizations, which was taking what we now call the multi-computational paradigm from the physics project and applying that to mathematics. But when you take things multi-computationally, and really just briefly, the idea of multi-computation is, once upon a time when we studied computational behavior, we would study behavior one computation at a time, one particular kind of evaluation at a time. You'd have some initial condition, you'd have some rule, and you would run it to see what it does. Now, you can do the same thing, but you're looking at many different evaluation paths, many different kind of threads of computation and the way in which they interact, which allows you to study, instead of just particular natural processes, entire kind of systems of these processes, how they work together. And one system is the system not just of mathematics, but of the way that mathematics is done actually by working mathematicians. And so metamathematics is this framework where you don't just do mathematics, but you show in a kind of a topological or graph theoretical sense, all of the possible ways that the working mathematician can do mathematics given a given setup, and how, in the kind of bulk limit, this produces these different kind of stacks of abstract technology that relate to each other in different ways. So this is a kind of a higher level view of mathematics. And then from there, with new concepts such as the Reuliad or multi-computational irreducibility, or with the identification of new opportunities to apply these methods to economics, to molecular computing, to distributed computing, to evolutionary biology, it was clear that there was a kind of a resurgence at hand, a renaissance, a kind of a spring, kind of a springtime for doing computational research, the study of computational behavior, but not like ever before. Now we have this new multi-computational paradigm. We have new concepts that need to be better understood. We have new areas to which these concepts can be applied. We have people who are interested in following it. We have people interested in contributing to it. And we're increasingly finding people who are interested in supporting it. And so we just want to create this really powerful machine that can make a serious impact on science, take these new ideas and, leverage the powerful technology stack that Wolfram Research has produced for all these years, leverage the experience that many of us have working at the company, or having been many of us are also alumni of the Wolfram education programs like the summer school or the winter school, and just, take this legacy that Stephen has helped to build, but write a kind of a new chapter, especially as young people who want to continue this work and continue it and make really bold advances into new territory. So that's the purpose of the Institute, I would say, kind of as a basic summary.
Yeah, that's great. Without getting into any of the details of the concepts that you outlined, because there were some questions specifically to sort of go over these concepts and clarify some of them. There's this question from the chartering thesis on what criteria are the fellows being recruited?
Okay. What makes me want to hire a particular fellow? So there are different criteria, and fellows can possess different qualities that are interesting and that are attractive. I mean, the first thing is that fellows are really interested in what we're doing. So they've done some work beforehand, and they've gained some kind of understanding of what we aim to do, and they kind of appreciate the uniqueness of it, and they're interested in it. So I'll say, for instance, I myself went to the Wolfram Summer School, and being accepted to the summer school was the best day of my life, at the time, and then things just kind of got better from there. But I spent every single day in preparation for the summer school reading, things that Stephen had written like in 1983, and just, from there, reading papers that other people had written that were kind of in that area. But I was just, completely obsessed. And I came to the summer school, having really absorbed these ideas about, there are terms from the 80s like autoplectic systems, but basically, I studied quite carefully things like algorithmic information theory, computational complexity theory, and I had really understood like how Stephen had taken a really quite different position on this, and I really internalized the philosophy, and I just thought it was the most exciting thing in the sciences that I've ever encountered. And um, I mean, that's kind of my case. Um, so one, taking a strong interest in what we do. I mean, many people who join will have some strong computational background. So if you take like Nick, for instance, I think Nick, maybe it's now 14 years, 13 years. Nick has been immersed in the study of Wolfram language for a long time, and he's just highly competent. He's very, very good at Wolfram language. Now, if someone is highly competent at something like Python or something, and they're ready to become kind of immersed in Wolfram language as well. That's always something that can be discussed. But people who are basically capable of computational thinking, they're ready to take that kind of immediate leap where they have some sort of a question, and instead of kind of just doodling notes on a napkin for months about it, they understand this notion of computational thinking where you have a question and then you find a way to pose it in computational terms. You find a way to build a function that allows you to experimentally and empirically, run some sort of computer experiment to begin addressing it, and you're able to take that leap from curiosity, from inquiry, to having actually somewhat nice looking initial results that kind of address that question, basically within hours or days. If you're, especially with Wolfram language, and if you're kind of computationally literate in general, you're able to use your cognitive skills to identify things that you don't know. You're able to use your cognitive skills to translate the questions you have into something that a computer can help you with. And then in this kind of cyborg-like way, you greatly augment and extend your cognitive abilities by having found something that's a question that could be translated into something that a computer can help you with, and then working with the computer to deliver these results in a highly timely way, an efficient way, and often with really kind of beautiful graphics and tables and kind of a well organized, well tabulated set of results. Another thing is people who have a kind of a startup like spirit, because we're a small organization, and just like any kind of, I mean, we're a nonprofit, right? But just like any startup, having a small team, having still a relatively small budget that could always increase if people are interested in supporting us. But beginning with a relatively small budget, but powerful technology and powerful ambitions, and just working just, I mean, incessantly, obsessively, insistently on, tackling something that seems ambitious, but knowing and having the conviction and the confidence that you can take this thing, we can use the kind of methods that we've been trained to use, or that as a fellow you will get trained to use by applying this computationally, and just through a few other kind of aspects of our culture and our method, taking things that seem really hard and making them real. I mean, this is something that like Nick and I, for instance, have done, with Stephen in the past. We take something that just seems like an impossible project, and through computation and with the right culture, you make it real. And I'll just say two things about the culture. I mean, one is just this really strong work ethic, but the other thing is this culture of, ultimately we take areas that have been pursued in academia or elsewhere, and we really drill down the concepts into the kind of like most, common sense, basic distilled notions of the substance, the real substance of the content. And once we really understand what it is that these terms or objects or concepts or particular language in some area, as soon as we really drill down and we understand exactly what it means, then we can convert that into something that's computational, and the kind of the machinery and this kind of post-human science, so to speak, can take it from there to some respect. So we're really in the business of innovating, of being completely unafraid of some area of science. Usually the areas of science that seem hard are just the areas of science that have been so poorly explained in this kind of cumulative way that it's very, very hard to find a kind of an entrance, because the entrance is is not obvious. And if you speak with scientists who are working, on the kind of the forefront, the language can be quite impenetrable, right? But we find a way to insert ourselves in. We really just bash our way in. And once we're in there, we're able to understand, what these concepts are. We can kind of liquefy those down to machine speak, and then we're in business. And then we're kind of making this stuff anew. So those are some qualities that I look for. Really kind of taking interest in what we're doing, having that boldness and that commitment to working on it, being computationally literate. If you're an expert in Wolfram language, that's really attractive. If you're an expert elsewhere in computation, or you have a kind of a good attitude about it and you're willing to learn, these are all good attitudes. These are all good qualities that I look for.
So Jens, just to sharpen whoever asked, because what I hear are the desiderata of people who are interesting profiles to work, but because they were asking for criteria, I guess they are, concerned with what kind of process the recruitment follows, or what kind of qualifications they can expect, or in a more systematic way. I'm guessing they might want to sharpen it that way.
I mean, if you have a strong grasp, like a uniquely strong grasp of what we're doing, and you have some proven track record, right? But you dropped out of kindergarten, it's okay. It doesn't. I mean, that I don't care about that to a certain extent. Now, if you drop out of kindergarten and you haven't made good use of your time since then that will be a problem. But what we're doing, on the one hand, methodologically, a lot of what we're doing is highly unique. So if someone has gone through, let's say someone is now a postdoc, and they've been trained in a certain methodology for, it could be like 10 years at this point, if they're a postdoc maybe, or if they're like a second, third, fourth, if they're in that postdoc holding pattern. And if I encounter someone like that, really the first question is, to what extent are they willing to, learn new methodologies, and to still be kind of vulnerable, and to still be willing to have a kind of a beginner's mindset, even though they've become highly trained and somewhat specialized. Sometimes people are lifelong learners, and they're willing to do that. I think, Carlos is a good example of this. Sometimes people feel as though, they went through all the pain of becoming a postdoc, and they just want to specialize on, I don't know, a particular approach to computing wavelets or something, and that's what they're going to do. They're going to go float amongst the wavelets. So that's fine, but that person's kind of less likely to be kind of useful to us. If you're like a domain expert, so like if you have a PhD in economics or molecular computing, some of these areas, people who have specific knowledge, who also understand what we're doing and have those qualities that I described before, that is highly attractive. So for these particular modeling projects, being able to leverage that knowledge is I'm looking for people who can do that. On the other hand, if you're someone who does not have many accreditations from more kind of standard institutions, you have to have some qualities that really stand out. You have to have done something that proves that you have a strong work ethic, or you have to kind of prove that you really kind of understand what it is that we're doing. So I will say, like, if someone applies, so if someone has been like to the Wolfram Summer School or something, that's like they've been kind of vetted to some extent. And like all three of us on this call have been to the Wolfram Summer School. Two of us were part of the same class, and Nick was a year joined a year earlier actually. If you haven't done that, I will have work trial programs set up. So if I don't know you and I've never kind of, met you and we've never worked together, I will set up a small project. You'll have like 2 weeks to kind of work on it with me. I'm happy to set aside some time to work with you on it. And that will be kind of similar to what you would do during the summer school. And so the test there will be, can you take an idea and make it into a real computational project in 2 weeks? It won't be of the same kind of scale as a summer or winter school project, kind of closer to a winter school project. So winter school, I think, is like 2 or 3 weeks. So for kind of fresh people, for fresh faces, we'll have a kind of a work trial set up. So some combination of me looking at your CV quickly, some sort of interview, and for people who are kind of new, some sort of work trial where we see what kind of computational research you can do. That'll be the main thing. But if you have a somewhat unusual background, it's not like if I don't see Princeton or what have you on your CV, then it's going to be an automatic no. I will take every individual seriously, and I will say the thing that really stands out for me is interest and the kind of the fighting spirit, but also some kind of core competencies.
Great. So
And there is,
Yep.
by the way, there is, so on the Wolfram Institute website, there is this page that says join us, and at the bottom there is a button that you can click if you're interested in contacting us and learning about what we're doing. So I'll just post that in the chat. So if you're thinking, well, I want to apply, I have all these great ideas about the Ruliad or what have you, and I need to contact someone, there's an email address there, and you can chat. We can start chatting immediately.
All right.
Hopefully people have questions for like Nick and Carlos and people too.
Yeah, we can get into those where we talk more about the topics, but there's a general question about affiliates. So Athena, who just was invited today, was asking, what does a research affiliate do?
Okay, great. So Athena is a somewhat special case. I'm not to embarrass Athena or anything. She seems like a quite bright young person. I mean, all of our affiliates seem like bright young people, but Athena might do something kind of special at the Institute, and other affiliates are kind of able to do that too if it's appropriate. But in general, the idea, so this tradition of affiliates began with the physics project itself. So back when the physics project was still without an institutional home, there was this web of volunteers, and those volunteers usually held some sort of a position at a university, or they were a student at a university, and they would collaborate, in a kind of informal way on projects that often had some sort of relevance, sometimes a kind of a loose relevance to the physics project. And we want to continue that tradition, but we're going to change the way in which it's done. So the first thing is, we want people, so if you're a student, for instance, we want people who are really interested in making a contribution to the research that we're doing, who also can kind of afford to do it time-wise, and it can kind of reconcile it with their university schedule. So often we ask individuals, if they're like a master's student or a PhD student, the best case is someone who's asked their advisor, and their advisor is either willing to let them do a thesis, or you could even be like a bachelor's thesis or something that pertains to this kind of research, because we're always looking to actually have some impact on work that is done in the academy. Or if you're like a second-year bachelor's student, even having a teacher who's willing to let you, it depends on your kind of program, right? But if you have a teacher who's willing to let you do some research with us as part of a project for a course of yours, people who have received some kind of approval or authorization to do work with us as part in some way of their academic work, that's always a bonus. That's more attractive to us. Now, if someone is, an early student and they're mostly taking courses that don't involve projects or something, I understand that it won't always be the case that it's kind of, there's any one that they can really kind of go to ask for approval. In the kind of more general case, what we're going to do is we're sending out invitations to these research affiliates. But in the past, we would have these research affiliates, and then you'd have like a one-on-one meeting with this individual, and you'd have some project, and you'd be working with that person. You'd have a one-on-one with this person. You'd have a one-on-one with this person, and we would have people not to call anyone out, but like like Xerxes, I think had quite a burden on him, trying to maintain interactions with all of these particular individuals. I happen to think it's not only more efficient from a managerial standpoint, but more effective in terms of in terms of guiding this research affiliate interest towards the actual research goals that we have at the institute. It's going to be more effective to assemble these affiliates into teams. So we're going to have teams that have areas of focus that are kind of directly mapped to goals that we have at the institute. So in terms of the physics project, for instance, right, we're pushing towards these models of QFT, GR, and ultimately quantum gravity from computational foundations. So we're going to have a group on quantum mechanics, QFT, et cetera. We're going to have a group on, general relativity, perhaps numerical relativity, cosmology. We'll have a group that's interested more generally in multi-computation and also things that are kind of related to that. So we're going to have a few teams. And so if you're a research affiliate, you get to actually, it's not just, if you're a research affiliate, you won't just have regular meetings with me or with Nick and we're asking you how your project is going. You'll get to jump into these teams. These teams will, if you're a bachelor's student, your team might have like a PhD student or someone beyond. So not to name names or anything, but if you're like a second year bachelor's student and you join the quantum mechanics or QFT group, you'll have people like David Chester, who's like, he already has a PhD and he's like a very, very, very good, at this point, professional physicist who will join you in that group. So I think that's very rich. I mean, both for the slightly more senior people to be able to work, to maybe serve as something of a mentor for these younger people, but also vice versa. But more so that you can take on more ambitious projects and you can delegate amongst the team and you can play to each other's strengths, and you'll be working with us at the Institute and you have a kind of your team is concentrated on a particular goal that happens to align with our goal. Now, I'll say one other thing about this. So often when I get applications for research affiliate positions, people will say things like, I want to do ADS CFT in the physics project, which we should absolutely do, right? But before we can do that, there are many dependencies, even in the title. You have to be able to define conformal field theory. You have to be able to define anti-de Sitter space. You have to be able to define brain bulk models. And there's quite a bit of dependent concepts at play in ADS CFT. And there have been some comments that have been made by people in the physics project in the past about the implications that the physics project might have for ADS CFT, or if it agrees with ADS CFT. But to really do it in a generative, thorough way from computational first principles, we have to be able to account for every single physical quantity or concept or property in the models. Which means if someone applies to be a research affiliate and they have a very specific project that demands mastery over conceptual dependencies that have not yet been addressed in the physics project, then it's like, okay, great. That is your end goal, and you're going to work with us to push this particular framework forward to such an extent that that question can actually be meaningfully, or that particular model or area of physics, or that finding in physics you can try to reproduce it, or you can explore it using our particular method. So, once again, if people are interested in research affiliateships, hey, Łukasz, I think, okay, he muted himself. People are interested in these affiliateships, once again, you can just follow that contact us button at the join us page, and we'll be happy to hear from you.
So I think there is a follow-up to what you were saying, and a colleague of mine just sent me a question. I think they use Twitch, but they were curious about this, and it's directly related to this. So the follow-up, I think, is who are the senior people leading the GR, QM, QFT, etc. groups, I guess relating to your answer. And then I'll pose the question that my colleague just sent, and we can answer that after because it's directly related.
So I can't answer the question yet about who's leading it. So Carlos at the moment is sending out the invitations, and Carlos will know better than I will actually who has accepted the invitations. What we'll do next is once we've sent out the invitations to research affiliates, and there are some kind of teams that are defined there. I mean, what I'll have to do and what Carlos will have to do and maybe some other people at the Institute will need to do is we'll look at these teams. We'll identify, who are particular individuals who are on these teams who have been involved with the physics project, say for some time, like maybe like at least a year or something. They have some background, and they also have time available to not only do their own work but to help kind of serve as a leader within the group. So it's not pre-assigned. We'll make those leadership determinations according to who accepts the invitations, what the kind of composition of the group is, because maybe there could be several leaders. It depends on who's in the group and how large the group is, and also the kind of the nature of the research that's being done. So if, sometimes these groups, they really have a few different topics assigned to them, and I've just tried to find topics or research goals that are largely compatible that can be kind of assigned simultaneously to a certain group. So there could be several leaders. It just depends on who we get. Now, ultimately, these research affiliates, they're not going to be affiliates in the sense that they're very far removed from the Institute and we don't check in with them. I mean, they, for those of you who have been following our live streams, I mean, I set a quite brisk pace for the research that's done at the Institute. So, I mean, every time we have a meeting, it's to discuss something new that has been done. And I'm going to be writing these Institute these Institute digests that summarize, research progress that we've made at the Institute. And you can expect like at least every month, but preferably every 2 weeks. It's like, just a kind of a substantive new update that shows new things that we've done. And the research affiliates are not going to be an exception culturally in that regard. So if you're going to be a research affiliate, you can expect to do real computational work at a serious pace, get real results. And, depending on the person in the background, that might seem quite different from a culture that they might encounter at their university, for instance. And that's what we do. We have different standards, we have a different pace, we have a different way of doing things. And so it will be very helpful for me and for other people at the Institute to have leaders in these groups. Otherwise, it's like I go from managing a team of a certain size to a team that's like double or triple the size. And that's it'll help to have leaders in those groups. But ultimately, the groups aren't going to be, semi-autonomous units. They'll just be units that have this kind of additional leadership capacity that's provided by kind of more senior people who are working on the project.
So just exact follow-up, they're asking, are current research affiliate on board automatically?
Sorry?
Are current research affiliate on board automatically? I guess, are they accepted automatically? Is that what they mean? Probably.
Well, it's kind of funny.
The ones that are currently affiliates, right?
Yeah, it's good. It's kind of a funny question because what we've done this time is we've just sent out invitations to people who have been research affiliates or we think could be good new research affiliates. So if someone's been a research affiliate for a year or two, what I did was we sent out this email and we said, if you'd like to reapply and be a research affiliate for this upcoming year, explain what you're interested in, explain your university situation, et cetera, et cetera, et cetera. And for the most part, when I sent, we sent that out to people, I shouldn't say for the most part, but we sent out that to, the research affiliates, and many of the people who are serious did respond, and we've sent them subsequent invitations. So I would not say that this is a kind of an automatic process. I mean, what we've done as a first step is we had these physics project affiliates, and what we did was we were able to get the serious members of that batch to reapply for Wolfram Institute affiliates. And so now they've received invitations to be a part of these various teams. If you're new and you're interested, then please contact us, please apply. But I can't guarantee that it's automatic, because especially if you're new, it's going to depend on many factors, like, like some of the ones that I mentioned. If you don't have any time, or you can't imagine doing it as part of your academic work at all, or you don't really have any background with Wolfram language, or if you don't have background with the Wolfram physics project, those factors, none of those are lethal, but for new people, have to kind of examine it on a case-by-case basis. So we basically don't do anything automatically. We're kind of a small operation. We have a quite specific culture, and we're looking for people who kind of either already get the culture or are very serious about becoming one of us and are willing to learn.
They're asking, are the ones who have been contacted automatically on board then?
We send them an invitation. If they accept the invitation, then they're onboarded. If you want to treat that as an automatic process, you can, but I would treat that as a manual process, because, okay, when I think about automatic, I think about, it's like it's automated in some way. If you mean automatic in the sense that, like, if we send an invite to someone and they accept, they're not signing like contracts or anything. So if we ask you, you want to be a research affiliate, and they say yes, like that's it, yes, then they're in automatically, if that's what you mean.
Okay.
Cool.
So I think very cool. Related to culture and to management, I think.
Carlos, you're on mute, just so you know.
Yes, sorry, I was mute. So related to management is this question: who decides the research directions and goals of the projects? Is James meant to direct the institute and manage every single research project?
So Stephen and I are the co-founders of the institute, and I would say that most of the projects are being determined either, I would say for the most part, Stephen and I kind of plan these out together, or we've kind of discussed them. For many of these, okay, let me take some specific examples. So like in the case of meta mathematics, for instance, this was an entire project that Nick and I did with Stephen. And then I had many kind of subsequent ideas about directions in which it should be taken. We've kind of discussed it, and I've determined, like, I think that, there are two particular areas in which I think meta mathematics should be taken, and now we're doing those. With something like the physics project, for instance, Stephen takes a quite keen interest in the physics project. And so, Stephen's quite interested, for instance, in this area of observer theory. So, I see it as my responsibility in the physics project to really ensure that we're taking the kind of the initial concepts that were specified and in the physics project, and really just making these fully computational, and then pushing towards QFT, GR, and ultimately quantum gravity. Once Stephen has some more spare time, because he's currently working on a project at the moment, once Stephen has some spare time, you can expect him to join in some of these meetings. And what will likely happen is that we'll have this kind of grand push for the physics project towards QFT and GR, and Stephen will become increasingly interested in this particular area of observer theory. And it'll likely be the case that people like Nick, for instance, who are working on this project, will probably help Stephen with particular research that he's doing on observer theory. So there are things that Stephen himself wants to do research-wise. And Stephen, for all intents and purposes, will be like a kind of a key scientist at the institute. So Stephen will be doing his own research, and there'll be people at the institute who will be helping him with the research. And usually, Stephen will do a project in order to write something that will appear on his website. And sometimes those things become books. But even when they become books, if you take something like the physics project as a whole, the physics project as a whole is something that's quite a wide project. It's quite a vast project with many different, various different components. And Stephen will usually write something that's slightly more specific, slightly more focused, that can be kind of put into a particular piece. So you can expect to see that where there are kind of specific slices through these larger projects that Stephen wants to focus on. And I mean, he's largely going to be determining how he approaches that and how people who help him on those. As for other projects, particularly like economics, Stephen is not really involved in that one at all. And that'll be something that I'm determining. I'll determine the kind of the scope of it, the original questions that are going to be asked, and we'll have fellows onboarded to work on it, and we'll have donors supporting it. I'm still looking for donors for that that particular project. So I would say, you know, as Steve and I prepared to launch the Institute, I mean, we spend a long time not only discussing the Institute, but really discussing the kind of the research that we have in mind. And that's why we launched this in the first place, is we had so many ideas, so many ambitions, there were so many things that we wanted to do that we just wanted to go do it. And so sometimes people are surprised that we have like quite specific ideas already by what we want to do. And it's not because we just decided to create an institute and then we thought, okay, now we have this institute. What the heck are these people going to do? It was the opposite. We had so many relatively concrete ideas of what we wanted to implement that we've now created this machine to just go out and kind of crank it out and do it. One caveat, though, is that usually these projects, I mean, the projects themselves are quite ambitious, and they'll only have some degree of resolution in their definition, you know, to begin with. So I would say at a high level, either I have a specific idea of what the project will be, or Stephen will, but then the actual implementation of it, the actual kind of structure of it as it becomes played out, the decisions that are made on the research level, the different kind of avenues that are considered, the methods that are developed, the functions that are built, the tests that are done. I mean, these are done in very close collaboration with the research fellows, and the research fellows do take on significant responsibility when they have a project assigned to them to make decisions and to try things and to be creative and to be inventive. So on the one hand, we have strong ideas for what the project should be, but it's not as though we have an idea for the project that's so carefully choreographed that the fellows are basically more or less being kind of programmed and doing something that's more or less deterministic, right? It's kind of like the overall theater is being set, and then the fellows take on significant responsibility on the creativity side, on the innovation side, as they work with us to achieve these projects.
So James, they're asking about this. You say that you had very specific, concrete ideas with Stephen, that you wanted to push forward. For instance, in relation to the Wolfram Physics project. So they're asking for these. What are examples of these very concrete goals and objectives?
Okay. Well, I mean, the first thing is, as I was mentioning, okay. So I mean, one obvious thing is just the physics project and splitting up the physics project into these general areas that I described. Okay, so that's kind of one obvious one. Now the other ones are, so we have this multi-computational paradigm, kind of general approach to doing computational modeling that has been kind of abstracted from and generalized from the physics project. And we saw a number of different opportunities to apply that to model other areas of science, or in general, other areas of study that we think can also be promising. So some of these include molecular computing, evolutionary biology, economics, distributed computing, also things like SETI, law and contract design. Stephen's also expressed interest in things like immunology, linguistics, etc. So there are many opportunities that we see to apply multi-computation. Now, some of these are better defined than others. And so what I will do is, kind of on a step-by-step basis, we will launch new projects. So right now we have physics project, metamathematics project, and RuleEd project. And we are looking for people who are interested in the RuleEd project. I'll explain RuleEd project in just a moment. But as we unveil new projects, what we'll do is I will release some kind of initial posts announcing that we have some new project. And that post will contain kind of preliminary research that's been done, kind of scoping out the kind of general research questions that we have, and including some kind of initial expository work showing kind of in general methodologically and paradigmatically how we're going to approach those specific questions. So if we take economics, for instance, economics is going to be the next project that is really launched. And so what I'm doing right now is, multi-computational time series, multi-computational Nash bargaining solutions, multi-computational approaches to avoiding arrows and possibility theorem in voting amongst agents. Et cetera, et cetera, et cetera. What does multi-computation have to say about the market efficiency hypothesis? Kind of taking kind of core, admittedly at the moment, somewhat academic questions in economics, and then just throwing multi-computation, throwing some areas of observer theory, doing, econophysics, I think has taken on somewhat of a bad name, but we'll be doing econophysics a la the physics projects. So we have like, branchial graphs and causal graphs and things that we use to model quantum mechanics or relativity, applying these things to economics. So I would say, sometimes people ask me, what are you going to do at the research at the institute? And I explain we have like 10 different projects, and they'll say, okay, well, tell me about this particular one. And some of them we have the kind of general intuition. Great things can be done applying multi-computation to this area, but we have not really begun to think about it in depth. And we're not going to hire fellows or fundraise or do anything for something that is somewhat amorphous, nebulous, or ill-defined as a project. What we're going to do is, I'm doing many things with the Institute at the moment, but one thing that I do in the background is I prepare the next project. So you can expect to see, I would say sometime in November. Oh my God, it is November. You can expect to see sometime this month a kind of a post summarizing this economics project, and then I would say, probably by hopefully January or so, we'll have both funding and fellows who will come in, and then we'll have live streams about, not only we'll have live streams about Langlands, and we'll have live streams about relativity, and we'll have live streams about combinator emulations of Boolean algebra, but now we'll have live streams on, Black-Scholes option pricing in the Ruyad, so to speak. So, and we're just going to keep doing that. And that's how this team will grow. We'll have more physics fellows, we'll have more mathematics fellows. We're also going to continue to launch these new projects and bring on fellows from there. Now, the other thing, however, is that each of these modeling efforts is informed by some common paradigm and by some common methodology. And there is still more to be done in the pure study of, say, the Ruyad, the structure of Ruyad, Ruyal space, things like Ruyal motion, Ruyal translation, really trying, ultimately, I would like to have, with the physics project, for instance, understanding our kind of place in the Ruyad, our scope in the Ruyad. I think, understanding Ruyal motion and Ruyal space will be very important for things like SETI, which we are actively pursuing. We might begin to do something in the area of SETI. New kind of methods that are being applied to study the Ruyad and the structure of the Ruyad, like N-machine theory. I've been working on this thing called N-machine theory for several months, which studies not just single pass in the Ruyad, but these like entire sheets and these kind of larger homotopic structures. That bulletin will also be released later this month sometime, but that's been some time in the making. It's just going through the editing process right now. So we're also going to have fellows who are working on the kind of core methods. So we have multi-computation, Ruyad, computer experiments, study of irreducibility, multi-computational irreducibility, et cetera. And then we have physics project, metamathematics project, and we're going to have new projects that are going to come out one at a time. And each time there's going to be a significant process undertaken in the background to study the area, to reach out to, say, our associates. We have research affiliates, but we also have associates, people who have led somewhat distinguished careers who are interested in collaborating with us. These people like Greg Chaitin or Bob Metcalf or Nassim Nicholas Taleb or Thomas Delian or Philip Rosedale, and that list will likely continue to grow too. We have kind of people in our network that we will also, confide in as we develop these. And so like one project at a time, we'll have something powerful and crisp and exciting to introduce to people. This is a new thing that we're going to do. Here are some kind of initial models. let's bring in some people who can help accelerate this, get some funding, and then boom, that's another project to add to our list. So that's the plan.
So to the benefit of the people who were asking, which I think they're asking very good questions, I think they're probably unsatisfied that they say you answer the physics project as one of the answers, and they say the physics project is not a specific idea, not even closed, and they were asking for a specific example. So I guess when you said that you had very concrete ideas of things to work on with Stephen, and particularly in physics, they were probably curious to know what these ideas are, and so maybe a little bit more of what did actually push the envelope here for the institute to be created.
I mean, if the question is what are more specific goals that inform the physics project, for instance, I mean, I will say at the beginning, right, the physics project itself just has a wide ambit purview in terms of the things that it wants to do. I mean, so the idea is there's been an initial kind of set of infrastructural assets that we have on the physics project for modeling quantum mechanics, for modeling relativity, and for doing some study of different aspects of space, such as dimension and curvature. So these are some kind of initial assets. Now, in order to get towards quantum field theory, standard model, and being able to model more effectively special and general relativity, we have to make many more physical quantities and concepts computational. So I would say, first of all, just being able to model from computational first principles, extending the framework to QFT and to GR are kind of general goals. However, I will say, and I said this during the launch, along the way, what I want to do is to identify foundational questions that have bedeviled physicists for a long time and use our new methods to make some sort of a contribution. So for instance, one thing that we can do with the physics project is we're not relying on some presupposed background space-time. We actually grow space-time, computationally. And so, there are all kinds of questions in physics about, whether or not you should be background dependent or background independent, and what are the kind of the flaws that, or the kind of the risks that you expose yourself to by simply kind of presupposing, background space-time. And there are foundational questions like the cosmological constant problem, for instance, that we very much should solve. So, cosmological constant problem, this gets down to, vacuum energy density and this terrible disconnect between empirical results and theoretical suggestion. I mean, it's an error term that's up to 120 orders of magnitude. Now, when you construct our models generatively, you begin at a small scale, and what we're doing is on the one hand empirical, because it's actually being done from computational foundations, and there's irreducibility, there's multi-computational irreducibility, there's higher rule irreducibility. You don't know what you're going to get, and so we can do real experiments, in silico, so to speak. But on the other hand, it's informed by theory, and the theory in many respects will agree with physics, but with kind of conventional approaches to physics, but it won't always. So I would say, on the one hand, just being able to emulate GR and QFT from computational first principles, these are kind of large goals. And then getting towards, say that like the standard model of the QFT side, being able to merge these and get a fresh theory of quantum gravity is the kind of the holy grail. But along the way, identifying serious conundrums, quandaries, crises in physics, and making a serious contribution to them, issuing that to the public and showing people, because I really want to show people along the way, right? It's not let's say all we did with the physics project was emulate existing physics. It would effectively be a waste of time. Maybe you could say, well, you've emulated everything, but you've taken it from computational first principles, and so you have a kind of a more parsimonious model, And so you've emulated everything, but because you did it from these simple rules, you've kind of made a contribution in favor of parsimony, for instance. But for me, that's not really enough. You want to emulate physics, but then when you disagree or you have some new insight, you have some new finding, you have something new that you want to contribute, you leverage the fact that you've been able to emulate all these other areas of physics. And then you identify, we've emulated all of this, but then here is a disagreement. This is something fresh that we have to say. Here's some new contribution that we can make. And so I would say, I mean, the kind of the general ambition has just been to basically to do physics at a high level from computational first principles. I want to add to this objective of along the way, really taking shots at these kind of hierarchy problem, cosmological concept problem, also questions like anthropic principle, et cetera, et cetera, et cetera. Really taking these on and producing kind of fresh answers to them. Hopefully there. I mean, I don't want to steal the show here. I have asked, people, Carlos, Nick, Wukash, to sit in on this, and I don't want you guys to just hear me lecture. So I mean, it's really great to hear that people have like these meat and potatoes, bread and butter, whatever other quaint, folksy metaphor you want to use, type of questions about like the actual way the institute's being run. That's really great. But I was hoping people would also ask questions about like causal graph embeddings and combinators and things that our research fellows could answer. Carlos, is there anything?
We have questions about that, but I guess some of our listeners were not perfectly satisfied with the concreteness of the answer, and I could maybe add myself that in the little corner that corresponds to me in the project that I'm doing, I sort of see one of the grander goals that are at the same time profound but also very concrete, which is this. The fact that we are going after models that use hypergraph rewriting, and we have this multi-way approach, which is obviously the rewrite approach, the approach that the computations are not necessarily deterministic in this sense. I see this as a very distinctive sign of or not sign, but the distinctive signature of the institute, and as someone who has come essentially from outside the Wolfram Physics project, as someone who doesn't have that much experience with Mathematica, I do see the potential to actually push in directions that the Wolfram tools are particularly well suited to help with. And so I can't really answer for the specifics of the physics project, and I understand that they are unsatisfied with the answer, but at least in what with respects to things like questions on to things on hypergraph rewrites and compositionality and this sort of higher mathematics that are really underdeveloped, and probably because we don't have the tools, and Wolfram technology is definitely a tool. Who can answer?
Well, look, I'll say one. Yes, this fellow is dissatisfied or perhaps somewhat of a heckler. I'll say this much: people often ask, what do you want to do with these kind of grand projects? And I'll outline, this is the kind of impact that we want to make. And if it's not specific enough, for whatever reason, sometimes people get upset. Like, how can you have this grand project if you can't be more specific about what you want to do? But I want to say something about doing a new science project where you take on some new methodological tools, right? I could be deceptive and try and say in advance, we have this new method that we're applying, and we're emulating specific aspects of physics, interpreting physics within this model, pushing forward this model, measuring new things, and kind of developing this step by step by step. But I can tell you in advance that 50 steps ahead, 100 steps ahead, we're going to encounter this, we're going to encounter this, this will be unexpected, this will be new, and that's going to be some great contribution that we're going to make. But that would be completely spurious, right? We have no idea what we're going to find with this project. Okay, we have this new computational method that we're applying. even when we've done simple things like trying to model, entanglement or reference frames, et cetera, every single step along the way, we find that new innovations have to be made to model these things. They give us new insights that can be leveraged multi-computationally to other areas. And so it's just full of surprises. And so I can't say in advance what we're going to find with the physics project. It's real science. I mean, I'll double down and say, if people are asking in advance for me to give a deterministic picture of what our scientific results aim to find for a kind of a grand scope like this, it's a borderline unscientific question to some extent. Every single step along the way when we develop this, there are going to be, terrific new surprises about insights that we gain about the kind of relation between computational foundations and physics. So every single step that we take, there are going to be new insights, and those are going to inform the kind of the next step that we take. So ultimately, what does quantum field theory look like in the physics project, right? I have absolutely no idea what it's going to look like. I mean, I can give you kind of intuitions about it. And if that makes you scared or skeptical, like, wow, these guys are doing science with uncertainty, that's unprofessional, then you don't understand science, right? I'll just say it flatly. The uncertainty coupled with the ambition and the conviction and the good work ethic and the ability for us to cumulatively leverage what we've done with time and push into that fog of uncertainty and reach from that new concepts and new objects. This is the kind of science that we do. So if you're interested in the mystery, if you're interested in watching us find new things, and you're comfortable with the fact, I mean, if you know the model in detail, that's one thing. And then you can say, okay, we're going to take this model, we're going to push it forward, add meat to it, and just one physical concept at a time, interpret that concept within our model and push forward. If you're not familiar with it, then we should have more discussions about what we're doing. But that's what I'll say. So if you're not interested in something that's a scientific endeavor that admits to some uncertainty, then well, that's too bad. I think it will limit. I think it will limit your scientific thinking, because you'll just cling to things that are already somewhat familiar and canonicalized. And I think in the sciences, that's ultimately somewhat of a decadent impulse. The prospect of uncertainty, especially if you can go one level lower or 10 levels lower, go all the way down to computational foundations, where it's totally it's unknown how to construct some of these things from pure computational foundations. That's what's exciting. So I'm very comfortable with the kind of uncertainty of this. And it's making these things certain. It's extending this framework further and further and further into physics, not knowing what we'll get, but being rigorous and accountable and systematic in how we do it. That's what excites me about the physics project.
So this member of the audience has replied to you personally. Probably should just read it on chat. Otherwise, I can just move on to the next question.
I mean, I think there are other people who have general questions about what we're doing. So
yeah. So there was a point on Mew and Maino asks, are you planning on having a research affiliate kickoff meeting?
Is this Mano? Mano, if this is you, then greetings. Yeah, absolutely. So I think, Carlos and I have to have a check-in about this. I think Carlos has been sending out invitations. This is something Carlos and I have to kind of do in the background. By the way, if you're not Mano, we know someone named Mano. So yeah.
He says yes.
Yes.
She.
Hi, Mano. Yeah. So once we receive kind of replies from the invites that we've sent out, then we'll absolutely have a kickoff meeting, and hopefully, Carlos, maybe without like naming names or anything, you've been sending out many of these invitations. Have you gotten replies from a lot of the people?
Yes, we've had about 6-7 replies of people who I've contacted, about 30 people, and we heard from.
Once we get to like 10 or something, yeah, I would say, within the next 2 weeks or something, we should have a kind of a kickoff meeting. So I'll see you there. Yeah.
All right, should we move on to more of the science questions on Discord?
Yeah, I only have 12 minutes, by the way, before I have another meeting. Um, so please, yes,
How should we use this time
Nick.
then?
Well, Nick, Carlos, please answer some questions about if there's something that relates to you guys. I feel bad having dragged you into this, and I thought people were going to ask you more questions about the science that you would answer.
Yeah.
No, maybe later. I was kind of thinking the same. You're gonna just answer questions on the organizational stuff all the way. So
Oh, really? Well, that's a good prediction. I didn't know what to expect.
Yeah, I think. I mean, there was a question about. Let me find it. I don't think it was formulated as. I don't think it was formulated as a specific question, but let me see. I think. Yeah. As I was asking, it would be useful to briefly describe a couple of concepts like multi-computation, computational irreversibility, hypergraph, branchial space, radial space. So I could speak to hypergraphs, and what I understood from James that multi-computation is beyond just having this general directed graphs and rewrite graph. As I think it's perfectly valid to ask them here. As is saying, ignore my question. No, I think this is a valid question. But we don't have much time, so we can definitely come back to this and have sort of basic questions. Because if you say we have 10 minutes, maybe it's best to direct everyone to the places online they can find us. I mean, we can spend 5 minutes. I can spend 5 minutes answering some of those concepts and giving a hint of what they are and some conceptual explanations, but if we only have 10 minutes, we have to be wise how to use them.
Yes, I mean, because we only have 2 minutes, maybe we probably only have like maybe 5 minutes. Let's wrap by providing some further details. For people who are on the stream or who watch it later,
Yep.
This is intended to be a kind of a community building meeting. So we should probably provide some other details about this in general. So one thing, I got a nice suggestion from someone actually, which is if you're interested in receiving updates about the streams that we have, we'll put together a kind of a list on our Discord so that you can actually get updates about these. I mean, we'll have a calendar, but if you actually want particular meetings to show up on your calendar, probably most likely will be these forum meetings, but if you want to attend other ones, we'll put together some kind of list, and then those can appear on your calendar. I mentioned previously that I'm going to be writing Wolfram Institute digests that are summarizing, the work that each of the fellows are doing. So, in Nick's case, we're going to be looking at models that he's developing for instance, modeling relative velocity between different reference frames. I mean, even some of the work that he's already done on causal graph embeddings, even some of those images are quite cool. So, I mean, what I'll try and do with the digest, and this will become increasingly challenging as time goes on, but I want to write something, it's like a paragraph or something, where I, highlight what the fellow has done, explain the general goals of the project that the fellow is pursuing, with this particular contribution, so that people can, even if they're not following us regularly, they can appreciate, okay, Carlos is studying, combinator emulation of Boolean algebra. This is the particular thing that he's looking for. These are some implications or some kind of exciting potential consequences of the research that's being done. I'll also announce new donors. So, we have a donor metaverse that I'll be highlighting in our first digest, and other pieces of news. If we have a new donor, if we have a new fellow, if we have a new partnership, if there's an event coming up, maybe a lecture in Cambridge or some sort of international conference that we're organizing with partners, we will be announcing all those too. So there'll be a mailing list. This will be, there were physics project digests in the past. I think unfortunately, because the physics project, prior to really having an institutional home, I think those digests were somewhat anemic, and that we were basically asking supporters to kind of live off of salt water. I would say they were kind of a low kind of caloric digest, to extend that digest metaphor, way too far, so to speak. For those of you who have kind of been interested in the physics digest, this will be kind of a more substantive, highly more substantive version. I mean, one, because I'll kind of handwrite them each time, but also because we have fellows who are working full time on doing this research. So on Discord, we'll kind of we'll invite people to sign up for those two lists, to have these events appear on their calendar, and also to sign up for the digest. Carlos, is there anything else on the community side immediately? I mean, we're kind of discussing some things in the background, but is there anything urgent or at least timely that we should share at the moment, you think?
So I'm going to post on chat for everyone to see. Just give me a second. I was just copying the final link. So those are the social links, basically. There's the Twitter, there's the email that you can use to join the mailing list, and then there's the direct link to Discord. So for anyone watching, or either live now or later in the VOD, follow us on Twitter if you want instant updates. Come to the Discord. That's where the actual community is in a real sense. And do email us if you want to be considered for the mailing list, although we will be announcing this later on, because we still need to properly figure out the logistics of how exactly we're going to implement it. And yes, and in general, the website, so I'll just, for the benefit of everyone, I'll just share the website link again. I mean, the website really is the nexus of all the information that we do. The live streams, the calendar soon will be listed there as well explicitly. So you refer to that website to find us. And that's everything I have to say at this point, I think.
Yeah, well, God, I really wish that Carlos, Nick, Łukasz could have spoken more about their research. I mean, one thing we can do next time, I had kind of suggested it this time, but we were kind of inundated with questions that took up all the time. But what we can do next time is, I think that the four of us, maybe there are more of us next to the problem. I don't know. It depends on when we do this next. Let's have a kind of a short roundtable, and I mean short, like 5-10 minutes, where we just discuss, what each of us is working on, so that people who are following this, who haven't been following the live science streams, have some understanding of what we're doing, and that can motivate, questions if they want to know about the physics project or metamathematics or something like that. So next time, let's hear from our fellows more, and we can do something also as we promote this to kind of set that up. All right. Well, excellent. This has been great. We've had more viewers than we have for previous streams, so this makes me happy. Now that might say something about how few viewers we've had, but we're just launching. So this has been fun. Thank you all for your questions, and I look forward to engaging with you all further. All right. Cheers.
Right. See you online, everyone.
Bye-bye.